Hi everybody. So in this video I'm going to show you how to use the inverse normal function on a calculator to find an observed value for a normal distribution. So in example 1, we're told that the masses of cats in a village are modelled as m being distributed normally with a mean of 8 and a variance of 0.4 squared. We've been asked to work out the mass m of a cat where the probability of a random variable being less than the observed value is equal to 0.25. So with questions like this, the first thing we should do is to sketch this on a normal distribution curve. So we know that the curve is symmetrical about the average 8, and we've been told that the probability of the observed value of being less than the observed value is 0.25. So this means we're looking at a region around here, where this probability is 0.25. What we want to work out is the value of m along this continuous scale. So what we know is that the area under the curve is 0.25. We know the standard deviation sigma is the square root of variance from 0.4. And we know that mu is given as 8. And we can enter these three values into our calculator using the inverse normal function. So if we press menu, we want option 7 for the distribution. Then we want option 3 for inverse normal. We know the area is 0.25, sigma is 0.4, and mu is 8. Press equals, so now we know that the probability of a random variable being less than 7.7302 is equal to 0.25. Okay? For part B, we're told that the probability this time of a random variable being greater than the observed value is equal to 30%. So again, we'll sketch this on a normal distribution curve. We'll label the average as 8, and because the observed value is greater than m, and this is 30%, this time we're looking towards the right of the scale. So we'll say this is the area of 0.3, and m is the value we're trying to find. So the way the inverse normal function works is that it finds the area to the left. What we have is the area to the right. But we know that the total area under the curve is 1. So the area we can put in will be 0.7. So if we go back to the inverse normal, this time we'll say the area is 0.7. We'll keep sigma and mu the same. So we know the probability of a random variable being greater than the observed value, which is now 8.2030 to 4 decimal places, and this will be equal to 0.3 or 30%. And for question C, the probability of the random variable being less than the observed value m, but greater than 7.6, we're told is 0.8. So again, we'll sketch it on a diagram. So we'll plot 7.6 about here, and we'll say m is about here. What we've been told then is that this area is 0.8. But we can work out this area as this region up to m minus this region. So if we say that 0.8 is equal to the probability of the random variable being less than m minus the probability of a random variable being less than 7.6. And we can work out m being less than 7.6 using the normal CD function on our calculators. So we'll go to distribution, we'll press 7. We want normal CD, option 2. The lower has to be 3 standard deviations less than a mean, or anything less than that, and I'm going to say 0. The upper we know is 7.6. We know sigma is 0.4, and we know the average is 8. So this gives us this region, which is 0.1587 to 4 dp. And then we can put this back into our equation here. So 0.8 will equal the probability of a random variable being less than m minus 0.1587. And then we can move this to the left-hand side. So we'll have menu, option 1, 0.8 plus its previous answer. So 0.9587 is equal to m being less than our observed value. Then we can work out m using the inverse normal again. And I'll sketch this separately. So we'll plot this at about here, when this region has an area of 0.9587. So we'll press menu, option 7, inverse normal. The area, 0.9587. Sigma is 0.4, and mu is 8. So this will give us our observed value, that m is equal to 8.6943. Okay?